Our next speaker is Shiraz Tayabji. Yes. He's the president of Advanced Concrete Pavement Consultancy, located in Elliott City, Maryland.
It's my pleasure to be here, and I hope I can provide you some information. On precast concrete pavement. This is a new technology. It's been around about 17, 18 years. We had the first production project in 2001. Some of the states here have been implementing the technology. Robert is here, and Steve just did a project 2 years ago. And I'll be talking about Steve's project a little bit in this presentation. So here I'm going to talk about this technology. There has been a lot of interest. A lot of states are now implementing this on a production basis, and many states have done their first project. So this is a situation. This is basically applicable to roadways with high volume of traffic, where you cannot go and do any lane closures during the daytime. Most of the lane closure has to be at night, and the work has to be done within a short period between about 7 p.m. to 5 a.m. in the morning. We have lots of congestion in our highways. I-95 is almost congested all the way from Washington up north. Any repair, rehab work we do, it has to be done at night. So we have been doing a lot of work using what we call high early strength concrete, at least as far as the concrete pavement repair rehab is concerned, but that has not really consistently provided good performance, or at least long-term performance. Whenever we are talking about repair rehabbing these high volume highways, we want to have a long-term solution. We don't want to do fix the fix, going back every few years and fixing what we have done. So we have been doing a lot of high early strength concrete. Hasn't really worked that consistently. If we do proper concrete placement using conventional techniques and so forth, we require longer lane closures, which we can't afford to do anymore. So the solution is to come up with a technology where we can do this work rapidly at night and still get long-term performance. And the precast concrete pavement, we feel, addresses this challenge. And as I think during the SHARP 2 program, we came up with this: for pavement repair and rehabilitation, shorter life cannot be accepted as price for rapid renewal. And I hope everybody takes that as a mantra. So now we are looking for a longer-term solution, but very rapid repair rehabilitation. I'm going to give you a brief background on the concrete pavement technology and give you two case studies. One, the Connecticut case study that Steve was involved in, or at least he championed it, and one project in Alabama. So this is what precast concrete pavement is. Basically, it's use of concrete panels that are fabricated and assembled off-site, transported to the project site at full strength, and installed over a prepared foundation. So the panels come full strength, 28-day strength, or whatever it is, at 14 days, and you install it. You don't have to wait for concrete to gain strength. So you can open it overnight, first thing in the morning. There is a requirement for use of rapid setting grouts and so forth, but it requires minimal curing. Within 1 or 2 hours, we get the strength we need, and we are able to open to traffic by 5 or 6 in the morning. Okay, so just a very quick example. This is Robert's project, 2010, I think. So this is I-295. This is repair application. Basically, we are going and doing full depth repair or full slab replacement. We are doing all the work similar to conventional repair, taking out the broken, distressed concrete, removing the concrete, preparing the base, installing dowel bars. Then instead of bringing the ready-mix truck with high early strength concrete, we are bringing concrete panels. We installed the dowel bars already. We bring the panels with dowel bar slats at the bottom. We place the panel where the slats are matching the location of the dowel bars. All of this work is done, again, between 7 or 8 p.m. at night. By midnight, we have done the preparation work. At around midnight, we bring in the panels. By 4 o'clock or so, we have installed whatever panels we want to install, do the finish-up activities, and by application of the grout in the bottom slide. So this is rapid setting grout. Within 1 hour it sets, and by 6 o'clock or 5 o'clock, whatever the traffic requirement is, we open it to traffic. The repair application, we can do about 15 to 20 repairs per night. This is another example. This is a larger project that we are doing now in New York, New Jersey, California, Chicago area, and so forth. This is a placement of 2,300 panels on this project 2 years ago. 12-foot wide full lane width, about 16-foot long panels, okay? California uses a metric system, so it's about 0.8 foot, so it's 9.6 inches, okay? So you can see this is around downtown Los Angeles, so lots of segments are being taken out. So this is what the project looks like. So we have a multi-lane highway. You can see the outside 2 lanes are distressed, a lot of truck traffic. This is about 40, 50-year-old pavement. So we are going to go in and take lane at a time. As you can see there, we are taking out the 2 outside lanes, but working on 1 lane at a time, about 600 to 800 to 1,000 foot sections. So under heavy traffic, there's so much traffic here that they couldn't work during weeknights. They had to do work only on weekend nights. So this is the steps. Basically, we are removing the concrete. We are opening up about 800, 900 foot lane, removing the concrete. In California, they also like to remove their cement-treated base or lean concrete base. So we are removing the concrete. We are removing the cement-treated base or lean concrete base, bringing in mobile mixers, placing a rapid setting lean concrete base. All this work is being done between 7 and 11 o'clock, all this preparation work. By midnight, we are bringing the panels. The lean concrete base, rapid setting lean concrete base has set, sufficient strength. We bring in the panels, we are starting the panels. We are placing 1 panel every 6 minutes. So we are placing about 10 to 12 panels per hour. So within 4 hours to 5 hours, we have placed 50 panels. Times 16, that's 800 foot length segment. By 5 or 6 o'clock, we are doing the finishing activities. You can see the grout placement, the bedding grout, and so forth. And by 6 o'clock, or whatever the time requirement was, 5 or 6, we are opening to traffic. Okay? So we can do about 600 to 800 foot every night. So on many of these projects in California, these are multi-thousand panel projects. So this is where we are right now in terms of the use of the precast concrete pavement technology. All the green states are what we refer to as production states. They are routinely using precast concrete pavement to repair their concrete highway pavements, as well as distressed asphalt intersections or ramps. The yellow states are demonstration projects. They've done at least 1 demonstration project. They're still waiting on the sideline for the right opportunities to develop and so forth. And the brown states are projects going in this year. Louisiana actually is constructing as we speak. Tonight they're doing the first test section, and then the rest of the placement will be during the month. Washington State is doing on I-90 a project, demonstration project, their first project later this summer. And Indiana is actually doing a project right now as we speak. Okay, so this is the quick background. We did the first production project in 2001 at Tappan Zee Bridge, the toll plaza. Again, used for rapid rehabilitation overnight. Typically 7 p.m. to 5 a.m. and typically single lane repair or rehabilitation replacement. So this is what it looks like. We have the repairs. We are taking out distressed joints or full slab panels, or we have continuous application where we have a single lane replacement like a ramp and so forth, or just a single lane of a mainline expressway, or multiple lanes. There's also a post-tension system. Typically, we are using jointed system. So most of our concrete pavements are jointed system, and we are replacing with jointed panels. But there's also a technique called post-tension system, where we connect up multiple 20, 30 panels together, post-tension them, and that way we get rid of the intermediate joints. We just have an expansion joint at about 200, 250 foot. It's not very popular, and California has done some projects, but I don't think it's, and Texas may do a project, but most of the implementation has been with the jointed system. So another view of the application. So this is the repair application and the continuous application in the bottom slide. we always need to provide load transfer at the joint. So we have different methods of providing. I'll discuss just now. So you can see at the bottom sketch diagram, the slats are at the top, and the photograph shows the slat at the bottom. So we have multiple different versions of how to provide load transfer. So our approach is this way. Basically, we are bringing the panel. This is a panel for like my iPhone on my hand. We come in and place it on a prepared roadway, and that is basically what we call a grade place system. More and more, we are using a leveling lift system because this doesn't give us the precise grade. When we place panels side by side, there is some elevation difference, and we have to grind it and so forth. So now we are using what we call grout place system. We are bringing the panel, leaving a gap under the panel using leveling lifts, about a 1/4 inch to 1/2 inch gap. We come back and fill that gap with the rapid setting grout. This way, we can use the leveling lift, adjust the surface elevation of the panel at the right elevation. Keep in mind that this is lane at time replacement, so the panel elevation has to match the adjacent pavements, lanes also, and from panel to panel. So this is another view of it. So this is using the leveling lift, grout supported system. You can see we have 4 leveling lifts at 4 corners, not corners, but at 4 locations. We set the panels at the right elevation, pump in the grout sets within 1 hour, we open it to traffic. The bottom photograph shows the continuous placement where tens of panels have been placed. You can see all the leveling balls, and then we go in and apply the bedding grout using grout mixers. This is the grade place system. Basically nothing new than what we are doing currently. We prepare the base, apply a bedding layer. We always need some sort of a bedding layer because the panels come with a smooth bottom. The panel bottom is very smooth. We don't want to have any point loads if we don't finish the grade well. So we come in and apply it. In this case, we are saying cemented sand bedding layer. We smooth it out and then place the panel over it. So that was the support. So we have 2 important criteria when we use precast concrete pavement. We have to have good support. We have to have good load transfer. Because the panels come with smooth sides, we also have to maintain a gap because we cannot place a panel in a hole within a precise hole. So for placing the panel, we have to have a perimeter gap of about 1/2 inch around the perimeter. We would like to have less, but typically it's 1/4 inch to 1/2 inch for joint, the transverse joints, and about 1/2 inch to up to 3/4 inch for the longitudinal gap. So we always have to have a load transfer system. So we are using what we call a modified dowel bar retrofit technique. We are using slats. You can see slats are at the top. One panel has slats at one end, dowel bars at the other end. So if the slats are at the top, panel with the dowel bar embedded and slide it into the panel that is pre-placed with the slats in front of it. If it's slats at the bottom, then basically we just bring the panel, slide the panel over the slat or the dowel bars in the previously placed panel or an existing pavement where we have drilled and grouted dowel bars. And there are other techniques. The third photograph shows a slat and duct technique. I'm not going to go into details because of the time, but there are different versions available to achieve what we call good level of load transfer. This is how the panels are made. So this is the jointed panels, typically made in the precast plant, 6 to 8 panels depending on the area available to the precaster in this plant. We have seen projects where they also do panel fabrication in and outside the yard. And then depending on the number of forms you have, you can do 10, 20 or more panels. But it's a very standard procedure. We are using a lot of reinforcement. The code, for example, Pre-Stressed Concrete Institute code requires 0.18% steel because we are going to be lifting the panels within 16 hours. So we cast the panels one afternoon, the next morning we are stripping the forms, lifting the panel, moving them. So every day we are fabricating that 8 to 10 panels. So there has to be sufficient strength, about 2,500 to 3,000 psi within 16 hours. And we need the steel, so if the panel cracks, nobody gets hurt. But from a pavement performance point of view, we don't need the steel. But because the steel is there, it helps. So if there is a crack in future, the crack will be held tight. All other requirements for concrete, for the precast concrete pavement panels is the same as what you would have for your normal cast-in-place concrete. This is what they do in California. Because they've got larger projects, thousands of panels used, they can't fool around with 8 to 10 panels per day. So they use pre-stressing beds. Here they can do single set of strands, 20 panels per night. Okay? So they save on labor, they don't have to set 20 sets of reinforcing beds and so forth. So just one set of tendons, they can create 20 or more panels depending on the size of the pre-stressing beds. And again, they would use steam cure, so within 16 hours or 20 hours, they're getting full strength, 4,000 psi. Okay? They strip the forms, and basically there's still a requirement for about 14 days at site cure, and then they're ready for use. So this is where we are. Fabrication, we can do 6 to 8 panels and maybe more depending on if the contractor wants to use an outside yard. 20 panels if you are using pre-stressing beds. Then during installation now, if you get a good project, we can do 15 to 20 repairs per night. For the production project, continuous application, the longer lengths, we can do 40, 50 panels per night. So you can see the problem here. We need to have a backlog of panels, several weeks to several months. So it's not like we award the project and expect the contractor to start placing panels within a week or 2 weeks. It takes several months before it even gets to the site. So just some construction consideration. Basically, we're using this technique to repair the surface layer only, as far as the concrete is concerned. In California, they go take out the surface concrete. They also take out the base. But in most of the projects in New York, New Jersey, we are basically removing the surface layer. We are reusing the base, typically granular base, at least in the Northeast, or asphalt-treated base. If it's asphalt-treated base, most of the time it will come out with the concrete as you remove the concrete. So you have to come in with a new base. If you are doing an asphalt rehabilitation, you are going to be using a new base. So in terms of new base, you can use a granular base, meeting your state specifications, or as they do in California, rapid setting lean concrete base. Okay? And in either case, whether you're using a new base or an existing base, you are grading it to as much to the level as you need, and then still using a bedding layer, which could be a cemented sand, or the grout, rapid setting grout using the leveling lift. Performance, some early installations we are still learning. There were some issues. As long as we know what the issues are, we can correct. There's not a problem. When we have some early age problems, we don't understand what happened, then we are really stuck. And then it gives a bad name to the technology. We have not really had any significant failures. The few failures or early cracking and so forth we have had, we know why it happened, and it's not happening anymore. We have done deflection testing, very good response at the joints and so forth. We get the best, we use the best concrete. It's very controlled in the plant. We make the panels very well, but the problem is in installation. If you don't have a good contractor or the quality control is not there, then the project is going to suffer. And we have seen some every now and then issues. There's always a question about the cost. 2001, $900 per square yard. Now it's about $350 to $450 per square yard. If you use high early strength concrete, we are basically $250 to $300 per square yard. So that's where we are. Hopefully costs will keep coming down. I'm going to give you a quick example of two of the projects. We had, there was a big study on the SHARP 2 program. We developed guidelines and so forth. And then FHW and Sharp II said this technology is ready for implementation. We'll support the implementation. So they came up with some funding, $300,000, supported several agencies to do their first demonstration project. The states are listed here, and these are the different projects they did. Hawaii did a project. It was the first one actually to do a project. Settled concrete pavement. They kept overlaying it with asphalt, and they used this to restore the elevation. And there's all these other projects. I'm going to just give you a case study of the Connecticut project and the Alabama project. So very quickly, this is Steve was the one who championed this, secured the funding, and made sure the project went well. This is part of the city fast track. This is the railroad track that was abandoned, and they decided to do a rapid busway connecting different cities. Unfortunately, the architect for one of the stations didn't specify concrete pads for the bus stop. So here we have, you can see the bus there. The asphalt keeps rotting. Within few months, it was rotting. They couldn't even open the bus doors. Okay, so they had to come, mill, and replace. So when this project came about, they said, okay, we'll just go in and do a precast project. So we got 2 bus pads in different direction, about 120-foot long segments. So they use 12 panels in each bus station, 15-foot wide, 9-foot long. So about 110-foot long. So that's the layout of the panels. This was going to be a weekend work. So they were able to shut down for a weekend, start work Friday night, remove the existing asphalt pavement, place a new base, and then during Saturday morning, place the panels, grout it and so forth, do the finish up work on Sunday, and open to bus traffic early Monday morning. So here I'm just showing some slides. The contractor, he removed the asphalt. Unfortunately, he ended up removing a little bit too much. So he came back and placed a loose granular material as shown here. So this loose material, typically we use it in a 1/4 inch to 1/2 inch thickness, but when it's about 3 or 4 inches thickness, there's no stability. So you can compact it, grade it, and compact it 10 times, 20 times. You can still go with your hands and lift out a bunch of the aggregate. So we realized that, and we told the contractor to remove it. On one bus stand, the time was short, so we had him remove it at the end 6 foot. When I say we, I'm just in a generic sense, but the DOT. And on the other bus stop, when there was still some time, they removed all of that loose material, replaced it with proper base material. So now we are placing the first panel, the next panel, you can see in the bottom, we got all the panels, 10 panels laid out. They're all with the leveling lift. They're set at the right elevation. We come back, grout it, and then by Sunday night, they came back and did the asphalt transition at each end. Okay, and that's what the bus stop looks like. It's been there about 16, 18 months now. 16 months. And I guess it looks pretty good still, no issues. This is another project, another unique use. This is a ramp coming off I-65 in Mobile, Alabama. A lot of truck traffic going to the port of Mobile, so lots of truck traffic. The ramp is an existing ramp was an asphalt 2-lane turn and rutting quite a bit. Hot weather, hot temperatures, and so forth. You can see the amount of rut. So every 6 months they would go and mill and replace. And when this opportunity came, they decided to put precast concrete pavement. So in this case, these are 2-lane. So they decided to use panels, 25-foot wide panels, and about 8 foot long, just because of the weight and so forth, 9-inch thick. That's what the panels look like. Again, this is with a leveling lift. So you can see the amount of reinforcement, panel at the precast plant. So now we are at the site, and the contractor is digging out the asphalt plus some of the base material, then grading the base, applying that cemented sand layer, and then starting to place the panels. So these are 25-foot wide panels. Halfway through, the hurricane came through, Irma, so they had to stop work, but they had a lot of traffic going over half of the project, no issues. It was able to accommodate all this heavy traffic. And you can see, again, leveling lift panels and so forth, and this is what it looks like. 2-lane, left-turn lane, heavy, reasonably heavy truck traffic, and a year and a half old. They're happy with that. So this is where we are. There are lots of states doing production implementation. I'm not going to read the list. We got some upcoming implementation. The first implementation in Indiana, New Mexico is doing one. In next year, Washington State and Louisiana are doing this year. Louisiana is ongoing right now. So summary, all agencies happy with the end product. For many of them, this was their first project. For most of the contractor, these are always the first project. If you have good plans and good specs, you are able to get a good product. So we have limited experience, but the oldest project is now 17 years old, the Tapan Z project. We don't see any issues with that, so we think this technology, if it is implemented correctly, we should provide us that 20, 30, 40 years of service. Okay? Thank you very much.
Any suggestions with CRCP pavement patches?
Yes, we just did a project last fall in Chicago. Okay? I-294, I-80, the Indiana tollway on the Chicago side. So it's CRCP. There were some issues, so basically we went in, took out the CRCP portion sections, and then came in with precast panels with heavy amount of steel that matched the amount of steel in the existing CRCP, so that 0.7% steel. So in this case, we end up using number 10 bars at about 12-inch spacing. We extended the bars out of the panels because they also then served as load transfer, dowel bars. So we brought in the panels, left a gap of about 14 inches between panels and between the existing. And then the first night we placed the panels and then put the dummy panels in the gap where the dowel bars were sticking out. The next night we came in, and when I said we, it's the DOT, of course, the contractor. They used high-strength, ultra-high performance concrete in the 14-inch slot the next night. So over a period of 2 nights, it was done. So there's continuity is maintained because we've got this number 10 bars coming out from the existing and from the panel in that 14-inch gap. Because it's a very high-strength material we're using, we only need a 14-inch overlap instead of the regular 24, 26-inch with the number 6 bars. And then the number 10 bars also provide the load transfer at those joints.
What did you do with the slot between nights?
No, we just take out the panel. It's a dummy panel. So we have the dowel bar sticking out, and then we bring in a dummy panel, that 14-inch long dummy panel with slots, and we just temporarily put the dummy panel. The next night we take out the dummy panel. And this is what we do at the end of every night. When the work stops, we put a dummy panel. So the next night, you don't have to dig out right at the end of the panel. You lift out the dummy panel and you start.
Do you tie the lanes together at all?
Yes, if it's multiple lanes. So there's a project going on in Hawaii, another project, about 1,200 panels. So they are doing multiple lanes because there's a lot of settlement. So there they are going to be tying the panels. Yeah, and the same way we have the slots and so forth. Yeah, top slot or bottom slot. Yeah, and use the same high-strength grout.
You know, I did one of these about 2000, and what I noticed is it's really difficult to get all the contractors' coordination just right because, well, they're leveling it out and you're waiting for the grout
Sure.
and so forth. What I'm wondering about that Los Angeles job you showed us, they must have had some experience before they went out there on that freeway to do that. I mean, they couldn't get it done there.
Yeah. So, I mean, that some early, what they call maintenance projects, where they did some small repair projects and so forth. So they did some learning there.
Okay.
And then California requires every major project, whether it's cast in place or this kind of project, a just-in-time training. So before the project starts, the contractor and the Caltrans, they pay an outsider, and I've done few of them, they share the cost, and you do a 4-hour just-in-time training. You go through the specs and experience from other projects and so forth. And the first 1 day or 2 days, it's slightly slow, but once everybody, the crew gets familiar with the process, it's production work, yeah. Thank you.
Thank you very much.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.